Hey guys, this is Miss Middleton. Miss Wesley is out, which means we have got to get some things done. And that means our bell ringer. So you're gonna go ahead, go into your courses. This is period 3. As always, your bell ringer is in the bell ringer folder. Go ahead, open that up, and it'll be the 3.1, 3.2 bell ringer organizer. So open that up. All right. Today's bell ringer, what does meta mean and what does morphic mean? You probably have heard of metamorphic before in your science classes when talking about a butterfly, or not a toad turning into a frog, a tadpole turning into a frog. So what do you think meta and morphic mean? Morph means to change, right? Animals morph. Meta means self, kind of. All right, so self, change. So today we're going to be talking about metamorphic rocks, if you haven't figured it out. So these are rocks that have taken other rocks and they change them. Okay, so after you have that down, which I guess I could like write down somewhere. So meta means self. Morphic means change. All right, so make sure that you have that as your answer. We are now going to finish our notes. Remember, you have a test on Thursday, which will go on marking period 4, but you still need to study for it. And that also means tomorrow, Wednesday, everything that you're missing is due. So if you are someone who is failing, make sure you check your email. I sent you a list of what you need to complete in order to be at a 70. If you are passing, way to be. I am thankful that I don't have to worry about you. All right, so you're going to go into your notes. Remember, your notes, if you go back to our main page, are going to be in the Unit 3 lithosphere, rocks in the rock cycle. And then your notes are right up at the top here. So click that and they will look like this when you open them up. All right, scroll on down. Talked about sedimentary rock. Today we're talking about metamorphic rock. All right, so metamorphic rocks are a type of rock which has been changed by extreme heat. Changed by extreme heat and pressure. Bam, let's highlight that. Now the parent rock, you could probably guess, is the original rock from which it came from. So what did it start as, and then what did it metamorphose into? Okay. Another vocab word is degree of metamorphism. As a rock material is exposed to increased levels of heat and pressure, the amount of degree of metamorphism increases. So increased level of heat and pressure, increased metamorphism. Okay. So more heat and pressure, more change. All right. Low-grade metamorphism, the rock still looks similar to the parent rock. High grade, the rock looks more like the minerals that make it up. So it's going to look a lot different. So for example, you have certain rock textures. There's foliated, so the rocks have a layered or banded appearance. So you guys know, or you might not know shale, but shale is made from mud, layers and layers of mud. You add heat and pressure and it becomes slate, which is like my chalkboard back here. This one's fake though because it's magnetic, but it has these thin layers. They used to use those for, and I grew up in a house that was like super old, like 1800s old. And so the roof for a while was like slabs of slate. So every time after a storm happened, my dad would be like, don't go outside yet. Let me check and make sure none of the slate roofing fell off because it was so thin that it would like slice into the ground and be sticking up. And so if one of us kids got hit by that, that could like definitely damage us. So you take slate, you add heat and pressure to it, you get phyllite, and you can see it's kind of, there's this weird like shimmeriness to it. Then you have schist, where you can actually see little minerals popping out. And then you add more heat and pressure to that. So each one you're adding more heat and pressure. So add heat and pressure to schist, and you get gneiss, where you have the minerals actually banding themselves and moving into lines, which is weird that happens. Scientists don't really know why it happens, but it does. All right. So foliated means layered or banded. All right. Non-foliated, these are rocks affected by heat and pressure, but do not have a layered or banded appearance. Do not have a layered or banded appearance. So an example here. So foliated granite, if you add heat and pressure, can become gneiss, as well as like if you increase shale, increase the heat and pressure, it'll eventually become gneiss. Non-foliated, this limestone, you add heat and pressure to it and it will become marble. Okay. Heat and pressure create metamorphic rocks and can be found in and on Earth in different areas. So mountain building creates huge amounts of pressures on rock. As you get deeper in the earth, you also have some heat. All right, so mountain building, you have mostly pressure. And as you can see here, you have slate, phyllite, schist, and gneiss. So this is where your foliated rocks are going to come from, mountain building, because there's a lot of pressure as it's squishing together and pushing upward. There's a lot of pressure, okay? So, and then heat, rock that is around magma chamber may experience just enough heat to change into a metamorphic rock. So it's not in the magma chamber, because if it becomes magma, it's going to become an igneous rock. But these rocks on the outside that surround it, they're close enough to heat to just be baked a little bit. And that's pretty much where the heat around a magma chamber. So magma chamber, just enough heat to change it. So let's highlight that. All right. So mountain building, you have a ton of pressure around a magma chamber. You're going to have a lot of heat to change it. Now, the last bit, the rock cycle. We already talked about this a little bit in the beginning of these notes. So this should be kind of a review for you. Okay, so the rock cycles, rocks are constantly undergoing changes from Earth's processes to form new rock. So rocks are, we'll just highlight that whole thing. Why not? The flow chart shows the way rocks change from one form to another. So we're going to double click and we're going to pull these over. So you're looking at these options, and it's always easier to start. I think it's always easier to start where magma is, right? That's an easy one to figure out. So we're going to take magma and pull it over here. Remember, in order to pull on it, you have to have the 4 like arrows pointing away from each other. So bring it over here. Bam, that's definitely magma. So I cool magma and I'm going to get igneous rock. So once you find one of these, it's easy to kind of go like, okay, we cool magma, we get igneous rock, we melt it back down, we get magma. If we weather and erode it, we're going to get pieces of sediment. So we take that rock, we weather and erode it, we get sediment. We compact and cement that sediment, and we're going to get a sedimentary rock. All right, then you can weather that if you want to. You'll get sediment again, you compact and cement it, which remember, compaction and cementation, you put those two together, we could just write lithification over this. That's the same process. All right, we add heat and pressure to any of these rocks and we'll get a metamorphic rock. Save and close it. And that's your notes. All right. If we go back here, hold on. All right, so if we go back to our Schoology, there's 2 things you got to do. The Metamorphic Rock Lab and the Metamorphic Rock CK12. I would start the CK12 until I get back. All right, so I can read that for you. I'm not going to read it for you. You can go through, you can read it, and you can start taking the little quiz with it. Okay? When we get back, I will start the Metamorphic Rock Lab with you. Okay? And you guys are responsible for the warm-up that I just made, or I just recorded for you, and the notes. Okay? You guys got this. I believe in you.